Okay, we're going to learn about 6.3. This section is called the traveling salesman problem. So let me set it up for you by introducing a story. So I've got a friend named Adam. He works in sales. I'm giving you a chance to write this down as well. True story. My best friend is a guy named Adam. He lives in Greensboro. He is in sales, and recently, this is last Christmas, he had to visit 5 clients who live in 5 different cities. The plane ticket cost is below. So the plane ticket cost is the only thing that is made up about this problem. Everything else about this problem is true. So we had to go visit 5 clients because what Adam does in sales is you're trying to build relationships. So if you're interested in working in sales, then this could be a great lesson and application for you. So what he does is every single year he goes and visits his 5 biggest clients. Sometimes it's 6 or 7, but last year it was his 5 biggest clients. And so what he did was he was able to buy his plane tickets and go fly and see these people. The problem is that they live, in this case, in this example, they live in Wilmington, in Charleston, in Atlanta, and in Knoxville. So they kind of live all over. And so Adam was having a problem being able to go and visit all these people because he wanted to be able to do it within a week. And so he wanted to travel and see them. Driving was going to be a lot of driving if he's trying to drive to each of these places. And so his company said, we will comp you a plane ticket if you can find a good price for it. And so he basically was given like free reign and given like $800 stipend to go and find plane tickets to be able to fly to all these different cities. And so what Adam could do is one hand, he can just say, you know what, I'm lazy. I don't really feel like figuring it out. I'm just going to fly in a circle around here until I get back to Greensboro. But what Adam did instead was he sat down and thought, okay, so how can I make the most money out of this? Because as you'll see, there are some strategies you can use that are fairly simple and quick and can help you save some money. So these numbers on the edges right here, these are the price of how much it costs. So again, these numbers are made up, but everything else about the problem is real. The cities are a little different as well. But Adam flew from Greensboro to Wilmington. We'll say the price is $185. So Wilmington to Charleston, we'll say that 121. That means how much it costs to fly there. So pause the video to write down the chart if you need to. I'm going to go through a couple things to know. So a couple terms to know. First of all, this is called a weighted graph. It's because it's a graph that has numbers on the edges. Specifically, this is called a complete weighted graph because notice, like we learned yesterday, every single vertex has a degree of 4. There are 5 cities, so every single degree should be 4. As you can see, Knoxville, for example, has a degree of 1, 2, 3, 4. So all the vertices are directly connected to each other, which makes sense because you can fly from Greensboro to Charleston to Wilmington or in any order that you want. The reason we're using a Hamilton circuit and not an Euler circuit is because Adam doesn't need to fly on all of these different routes. He doesn't need to fly Greensboro, Wilmington, Charleston back to Greensboro because he's then wasting $119 in time to go back to Greensboro when he needs to visit Atlanta and Knoxville instead. So this is an example of when you would use a Hamilton circuit and not an Euler circuit. You don't have to drive up and down every single edge. You're just trying to get to all the destinations and get there as quickly or as cheaply as you can. So the way you can measure your weights on the edges, which is your second term to know, is by prices, like we have in this example. You could also do like miles or a distance, or you could list it in time. Some TSP examples that you could see. So routing school buses. So you may know this already, but Miss Clemens, our administrator, she's in charge of routing school buses every single year. And so what happens when a neighborhood has a bunch of students graduate and they no longer need the bus, or maybe they move up from freshmen and sophomores to juniors and seniors and they start riding or carpooling with people, then all of a sudden they may not need the bus as much anymore. Each bus stop could have 20 to 30 bus stops. So that is, and this graph has 5 vertices. Imagine trying to do this problem with 20 to 30 stops. And so you're trying to figure out what is the fastest way that you can get the bus to all the different stops and come back to Tabor before school starts, because you don't need to drive up and down every single road in Winston. You just need to go to all the different bus stops. Another example or a job you could see this is in delivery services. If you're delivering pizza, you're delivering for Jimmy John's, any kind of delivery service like that, then you would look to make sure that you're trying to get to all your destinations you're trying to get to as quickly as you can in order to earn your tip. Trash, any kind of like trash service, mail service, anything like that, recycling. You're trying to visit all the different places, all the different houses. Those would be your vertices. You don't necessarily have to drive up and down every single road. You're just trying to drive so that you're able to visit every single house. Mail is another example. UPS, USPS. Um, UPS put out some numbers a couple years ago, and they said that on average they have about 300 packages on every single truck that they have at the start of the day. So 300 packages means a graph that looks like this, except it has 300 different vertices. And so a lot of times you have computers, which is why this is a computer science class. You have computers that are able to figure out what is the fastest way to get to all those different destinations, because you don't want to drive back and forth across Winston. You want to make your trip as quick and as cheaply as you can. The last one, let's say you don't want to work in sales. You don't want to route school buses. You don't want to work for anything where you have to deliver anything. Just in a everyday general life, everyone can use this when you run errands around town. Let's say you have to go to the doctor, you have to go to Chick-fil-A for lunch, and you want to go over to your friend's house. And so what you would do is you would figure out, well, what's the fastest way I'm going to get to all three of those places? So you've actually been doing Hamilton circuits for a long time, but you may not have realized it. And so the hope in this is that you can now use these to help you figure out what is the best and fastest way I can get from one destination to the other. So the running errands could be, maybe I need to go to Chick-fil-A first because I live close to it, and then maybe I need to go to my other destinations after that. So that's an example of when you could use this in your life. So all of this sets up what a traveling salesman problem is. Sales are a great job. You can make a lot of money in sales. It's a great career. You can travel a lot. You can work out of your car. You get to meet a lot of people and work with a lot of people. I would love to talk to you more about sales if that's something you're interested in doing, because it's a great career path. If you're interested in working in sales, then this could be something you can actually do. So we're going to get in the next lesson about what Adam ended up doing and how much money he was able to save. Because again, he got an $800 stipend from his company. So in the next video, we'll get to what he did and how he was able to save some money.